Hello there. In this class we are going to be introducing what Boolean algebra is. This class will be pretty much shorter because we are just giving a smaller touch to Boolean algebra here. So if you guys are familiar with the word algebra, you know that algebra is this tree of mostly variables and operators and functions and some theories, theorems and all. The same Boolean algebra is pretty much the same as algebra. There is a slight small difference between both of them. In Boolean algebra, first of all, let's see who introduced it. The guy who introduced Boolean algebra is George Boole. I don't remember the date he introduced Boolean algebra. Now Boolean algebra is simply the algebra of 0 and 1, because the variables here are going to be binary. Whenever we use any variable in Boolean algebra, it is going to be binary. It means its value, it can either be 0 or it can either be 1. If you see the normal algebra, there the variables had a broader range of variables values. No, we have values from 0 to 9 in their combination, so it becomes like pretty much broad. But here in Boolean algebra we are only limited to 0 and 1, so the variables here are going to be only 0 and 1. So you can simply say that it is a mathematical system where we use Boolean variables, and then we have some theorems, and then we have some laws, postulates, then we have some functions and all, just like the normal algebra. The main difference is the values that we have here. It's going to be only 0 and 1. Now why are we discussing Boolean algebra? The main purpose of studying Boolean algebra is that as we are discussing DLD, we may discuss logical design of a computer after like this chapter, but to represent that logic design in a mathematical way, we will use this Boolean algebra. So that is the reason that we are studying Boolean algebra. So after that, there are some components or elements of Boolean algebra that we are going to be discussing throughout this chapter. I am just trying to give an introductory touch to them. So the first of all, the most important thing in any algebra is the variable. Definitely the variables here are binary. Their values can either be 0 or it can either be 1. To denote these variables, we will use either capital alphabets or we can use non-capital alphabets. Apart from that, we will also have some operators. Just like the ordinary algebra, we will have plus operator here which represents the R operation. We have and dot operator here which represents the AND operation. We have a complement here which represents the not operator. Now we will see what are these operators. In the next video our discussion will be on variables and operators. Then we will have some expressions. By combining these operators and these operands mean these variables, we can create combinations, expressions. We will use these things in the preceding classes. After that, we will also have some truth tables that we will discuss in this chapter. Truth tables are what? Truth tables, if we have multiple variables, and if we want to see the relationships between all multiple variables, we will see the all possible combinations of the values that they share. So for those we will use truth tables. These are also something that we will discuss further in our course. Then we have some simplification methods. What are these? We will have some Boolean expressions which may be too complex, which may be too difficult to deal with, so we will try to simplify them using some simplification methods that we will discuss. One of them is also a graphical method that we have, Karnaugh map, that we will discuss in our succeeding chapters. So we also have some graphical maps to do the same thing. So this is just an introductory touch to this one. So in the next video we are going to be seeing what Boolean operators are and what are the truth tables and how do we create truth tables for certain number of variables. Thank you.